start with the no calculator section. And I'm going to just go over some quick tips with you for how you can do this efficiently and then use certain pieces of data to help you eliminate choices that cannot be possible. So for the first one, you're telling whether the function shows growth or decay. So remember the rule is if it's exponential growth, the base is greater than 1. Okay, so we know that it's exponential growth. Okay, and you can see most of them say exponential growth, but this one says decay, so you can cross that off right away. And then the other thing that you can pick out from the equation is the y-intercept. In this form, a is the y-intercept. You can also plug in 0 to find it. So once you do that, the only one that has the correct y-intercept and growth is B. This one does not have the correct y-intercept. This one does not have the correct y-intercept. So that's all you have to do is those two things, y-intercept, and then is it growth or decay. For number 2, this is about money, and there is a percentage. So you might get the growth formula confused with the PERT formula, but remember, you use PERT when you're compounding continuously. Okay, that's the formula with E. For this one, you have to use the growth. Okay, so it's a value that's increasing, which is growth. And then when you're writing the function, make sure that you have your variable in it. Okay, and then for 3, the inverse operations, that was in 4.2. You have to switch the x and y and then solve for y. So do -2 and then multiply by 3. When you multiply by 3 to both sides, you have to distribute, and then that's your inverse notation. Okay? All right. Let's go to the next page. All right, so number 4, we did part of that together. If you didn't write down what I wrote down yesterday, I'd make sure that you watch the video or write some notes down right now. So yesterday we wrote out the way that this is going to be worded is that an output is a function of the input. So identify what the output and the input are for this particular situation. So it says at x thousand feet, and we're talking about sea level. So what we did is we wrote out for the function, it's the boiling point of water as a function of the number of feet above sea level. That's measured in thousands. Okay? When you are doing the inverse, the output and the input switch. Okay? The way this is on your test, it's the same language. Like in the middle, it should say is a function of. You just have to switch the input and the output. And the nice thing about the multiple choice is you'll be able to see what the two values are, right? So again, what I find helpful is using the equation given and then thinking about what the output and the input are and then switching it for the inverse. So for the inverse, we have the number of feet above sea level in thousands is a function of the boiling point of water. Okay, so you flip those two places. All right, and then I felt like 5 went really well for you guys. This is what we just talked about on your last quiz, right? Rewrite with the same base, and then you can cancel out. For 6, you have the plus. Remember, you are going to have those rules on your formula sheet, so you can look at those. I apologize for making you multiply a decimal there. Okay, when you're multiplying the decimal, you just move it over, multiply like normal, and then move it back. Okay, I try to make the review more difficult than the test, so when you get for the test, you're like, oh yeah, this is as bad as I thought. And then once you get here, log base 7 of 343, that's going to simplify to 3. Again, when it's multiple choice, make sure like you have the log base 7. If there's one that has a log with a different base, cross it out. Right? Use your process of elimination to help you. And then 7 was similar, except you're using the quotient rule. Okay, and then that's going to simplify to 3, so log base 4 of 64 equals 3. You can see I just did like my division work over there. Okay, express this as a product, so the exponent goes down in front, and then rewrite with the same base. So 125 with a base of 5 is 5 cubed. Once you cross those out, you do have to multiply those two remaining. Because remember, this comes down in front, so you end up multiplying them together. I know 9 was a little tricky because some of us tried to do the product rule first, do the quotient rule first, and simplify. So x squared divided by x is just x. So it should be log base 3 of x. For number 10, this is similar to what you guys did on the last quiz that we went over, where you have to rewrite them with the same base. So 5 cubed is 125, 5 squared is 25, and then once you do that, you can set the exponents equal. Just again, be careful, make sure that you distribute. Okay, so distribute here, and then you're going to solve for x, and you should get x equals 6. And then you can see I checked mine too to make sure. Yep, 5 to the 12 equals 5 to the 12. Okay. All right, for 11, when you simplify, you have the natural log and e. Remember, they're inverses, so they undo each other, so you would just be left with 4x. For number 12, you are doing the transformations. Okay, the transformations are something that we've worked on with a lot of the different sections, right? A lot of the different formulas. So if it says it's transformed 4 units to the right, remember that rule for 4 units to the right is f of, and sometimes that's what I do. Like I'll say, oh, this is 4 units to the right. That means it's f of x minus 3. So when you plug that in to your equation, okay, it's going to be 0.3 to the x minus 3. That's the first step. And then it's compressed vertically, so that has to go on the outside. So then usually this goes in parentheses. I know some of you may have put parentheses around that whole thing. Like I wouldn't mark that wrong, but this is multiple choice. So just make sure you know how to recognize the different forms. And then it's reflected across the x-axis, which means the negative goes on the outside. Okay, so that's going to be your final answer. And then another thing I just wrote down on here is like, oh, what if it was a log function? If it was a log function, right, then the x minus 4 would go inside here. Okay, but it's always the x minus 4. Okay, if it's a vertical transformation, that goes outside. If it's a reflection over x, that goes outside. Okay? Just make sure you're familiar with those rules, that you remember those rules. Okay, and then 13. So we started 13 together, where we talked about normally when we make a table, we have -2, -1, 0, 1, and 2. But for this one, you have a log. So if we want things to cancel out, we want to use that same base. So if you can't see the base, it's base 10. So then remember we set up 10 to the -2, 10 to the -1, so those would cancel out. So when you do the calculation, you should get -1, -2, -3, -4, -5. Do you guys remember that from yesterday? We did those out together. Okay, so, and again, because it's multiple choice with the graph, another thing you could do is look at the graph, plug in the x value, and then see what your y value is going to be. The asymptote for this is x equals 0. That's because it comes from whatever your log is of. So this here, the only thing this log is of is the x. So that's why we know it's x equals 0. If it was something like, I'm going to say, for example, if it was negative log of x minus 3, that's when you would set that whole thing equal to 0 and solve. Right? So basically you're looking for the parentheses, and if there aren't any, it's just the x equals 0. Okay, so that's just a different example. Anytime you are talking about the asymptotes, if it's a log function, the asymptote is always going to have what form? So there's logs and there's exponential. If it's a log, it's always x equals a value. Okay, that's called a vertical asymptote. If it's exponential, it's what? Yes, a horizontal, so it's y equals. Okay, so if it's a multiple choice, what I would be looking for is there's probably an answer that has y equals 0. If there's something that has y equals and it's a log function, no, that can't be the asymptote. If it's a log, it has to be the x equals. Okay? And then you did the transformations. So this negative in front here, that's the reflection over the x-axis. This minus 3 is a vertical translation 3 units down. Okay? It would be a horizontal translation if it was inside the parentheses. Okay? All right, and then for 14, when you are doing the graph, again, I can't do e to the second power off the top of my head. So let's figure out things we can do with mental math. What number could I plug in? 0. If I plug in 0, I'm finding what point on the graph? I'm finding what's the special point called? If you plug in 0, what are you finding? The y-intercept, right? So the point 0, 2, the y-intercept should be 2. Okay, well this has a y-intercept of 2, so that's great. This has one of 4. So this is not the y-intercept that I need, so that's gone. For C, okay, that's not the y-intercept, so that's gone. For D, it's the same thing. It's negative 2. So see how just that one piece of information eliminated all the answers except for one? Okay, and then you could just do some additional checks. Like you know that this negative means it's a reflection over x. So if you know that the parent function looks like this, then you're like, yeah, that makes sense. And then this is the horizontal asymptote, so that means it should be going to the value of 3, which this one does look like it's doing that at y equals 3. So that makes sense in terms of the problem. Okay? And then 15 is very similar. So it says make a table and graph the function. Okay? I'm not going to waste my time making the tables when I'm looking at the tables and a lot of them are similar. So instead, let's focus on this equation, pick out something that I know. One thing I notice is they talk about the horizontal asymptote. So this is going to be y equals negative 2 because this tells you this is an exponential function. So an exponential function has a horizontal asymptote, and that's going to be the same as whatever your transformation is, up or down. So y equals negative 2. Okay, so it says horizontal asymptote here. All right, so that's a contender. This says it's a vertical asymptote, and it has x equals. No, that would be for a log function, so that can't work. This is a possibility. This is y equals negative 3, so no. So again, I'm just down to 2 answers. So if I look at the answers, they both have the same transformations. The only difference I notice is this. Here it says 3 negative 2. Here it says 3 negative 1. How can I figure out which one is right? Yeah, what can I plug in? Plug in 3. So this is 3 to the power of 3 minus 2. So 3 to the 0 minus 2. 3 to the 0 is 1. 1 minus 2 is negative 1. Okay, so it has to be A. Negative 2 is not the correct number. So, and I'm also modeling for you how I'm showing my work for multiple choice. Okay, so that's what I'm talking about when I say, oh, make sure you explain or just show me something. All right, 16. So you will have one that's like 16 in the sense that you're going to have to plug some things in. But 16, the number on there was very large. And the one that is on your test is not going to be as large of a number on there. Like it was the scientific notation. I said that you could leave it like this, or if you wrote it in scientific notation, that was fine too. Okay, so for 16, the main thing is that you're understanding where you are plugging these in. So it says the magnitude, the Richter magnitude of an earthquake M is related to the energy E. You have your equation, and then it's 7.8 on the Richter scale. So, and then look here, it says find the energy. So that means you're plugging in 7.8 for which variable? Yes, this is going to be your value of M. So you have 7.8 equals 2/3 times the log of E over 10 to the 11.8. And then from there, your step to solving with these is pretty much identical for most of these story problems. You always want to move over what's in front of the log. So how can I move over 2/3? Yeah, you can multiply by the reciprocal. Great. If you wanted to divide by 2/3, you could also do that, whichever one you want. You should get 11.7, and then from there you have the log of this value. Now the one thing sometimes that people forget is anytime you have a log, you can rewrite it as what? Yes, so rewrite this as exponential. What's the base of your log? 10. So this is 10 to the power of 11.7 equals E over 10 to the power of 11.8. This is the definition of a log, and that is going to be on your sheet, but you do have to know how to recognize it, okay? And then anytime you're solving for a variable that's in the numerator, you just have to multiply each side by the denominator. Okay, and then you can multiply both of these together in your calculator. I know some of you did that. That's perfectly fine. Or whenever you're multiplying by numbers that have the same base, what can you do to the exponents? Yeah, so you can just add 11.8 plus 11.7. And like I said, you could leave your answer like this. Okay, or you could do 10 to that power, and you get 3.16 e to the 23rd, so it's times 10 to the 23rd. So either one is fine. Okay. All right, for 17, you're trying to find how many years it'll take for the amount to be more than 1,200. So we're going to set this equal to 1,200 and solve. So when I say that the process is the same for these story problems, I mean that you repeat the same steps over and over. So you're dividing by what's in front of the exponential function this time. These actually cancel, so you have 1.025 to the 8t. Now again, you have a variable in the exponent. The way that you get that down is by taking the log of both sides. And really, you can choose what log you want to take. Like you could even take the natural log if you wanted. But once you do that, once you take the log, now we can use the product rule. 8t times the log of 1.025. You can never just divide by the log itself. I think some people try to do that in this one. But you can divide by the log of a value. When you do this, I would divide in 2 steps. Okay, so I would divide this on my calculator, and that would equal 8t, and then I would divide that value by 8. Or again, if you do it in one step, you're going to have to put parentheses around it. So if you get like, I think it was 25 something. If you got that, it's because of the way it was put in your calculator. Okay, so you either have to do it in 2 steps like this, or you have to put parentheses on the bottom around the 8 and the log. Okay, so I did this in 2 steps. This is what you get for the first step, divide by 8. Okay, so it's about 12.6. And then again, just be able to identify with your answers. So it might be 13. 13 might be one of the options. Okay? 12. It might be 12 or 13. Which one would it be? 13. Okay, so just use your rounding rules there. All right, for 18, that is the one where it says in it that you are compounding continuously. Okay, so that should be your clue that you're going to use this formula that I wrote above. This is the PERT. PERT goes with compounded continuously. Okay, so P-E to the R-T. Your principal is 15,000. Okay, the 6.5% has to be written as a decimal, 0.065, and then the investments after 4 years, and then you're going to calculate that. Okay. All right, and then 19. So this is the half-life. Okay, when you're doing the half-life, the first step is always the same. This is what we did the other day. Also, this formula is going to be on your formula sheet. So know that that's going to be for the half-life. When I say the first step is always the same, I mean you're always setting 1/2 equal to 1, and then times e to the negative k. The only thing that changes is the t. Okay, so the half-life is the 1.94 minutes, and then we're going to solve this. Okay, so to cancel out the e, I'm going to take the natural log of both sides. Okay, and those will cancel. Negative 1.94 times k, and then you divide both sides by this. Okay, and then let's round that to 5 decimal places. So you do the natural log of 1/2 divided by negative 1.94. And then you should have got 0.35729 if you went to 5 places. Okay, if you went to 4 places, that's okay. You should still be able to get the correct value. And then your second step is when you start using these other values that they give you. Okay, now notice that they gave you an extra piece of information here. It says they successfully synthesized 1,500 atoms, but then it says to the nearest minute, determine how long it will take for 800 atoms to decay to 7.25 atoms. So this means the 7.25 is your remaining amount, so that goes in for n of t. Your initial amount is 800, and then it's e to the negative 0.35729. When you solve for k, that should always be positive, so that when you plug it back in here, it's a negative exponent. And now you're solving for t. So again, your first step is always moving over what's in front of the value of e. So dividing by 800, and then don't worry about computing this yet. We'll do that at the end. So then you have the e to the negative 0.35729. And then the way that you bring that variable down is to take the natural log of both sides so that they cancel. And then your last step is going to be to divide by what's in front of the t. Okay, and then from there, when you round, you get about 13 minutes. I think the value was like 13.1 something. Okay, so it says to round to the nearest minute, so 13 minutes. Okay, so use your rounding rules there. All right, for 20, what function is vertically stretched by a factor of 2? So I know that has to go on the outside. If it's vertically stretched, it's a times f of x. So right away, b is gone because I would need the 2 out here, and this is gone because I would need the 2 out there, and it doesn't have it. Then it says it's translated 3 units right. Remember that rule is x minus 3. This has x minus 3. This has plus 3. So this would be to the left, not to the right, which means your answer has to be A. Okay, for 21, to find the constant ratio, which I feel like you guys are pretty good at, you're going to take the second value, put it over the first, the third value over the second, so on and so forth. Make sure they're the same. Now, when this is 0.83 with the line over it, you can't just do 8.3. You got to throw a bunch of 3's in there. And then see how it's going to round to 3? Oh, I put my decimal in the wrong place, sorry. 0.83. I'll just throw another 3 in there. There you go. And then see how if I throw a bunch of 3's in there, it's 3 exactly? Yeah. Okay? So if you just did the 0.83, you probably got 3.1. And then, so yes, the constant ratio is 3. Remember that also becomes the base in an equation. And then the y-intercept's on the outside. All right, now 22, okay? 22, depending on what values you used for this, that's going to depend on what you got for your final answer. So the way that we do this is where you enter in your list, your L1 and your L2. You go to Stat, arrow over to Calc, do exponential reg. Okay, what I recommend is that you do the 0, 1, 2, or in this case, like if you did the 1, 2, 3, that is fine. So if you did the 0, 1, 2, which is what we normally do, this should be your function. Okay, so you would go to Stat, okay, and then you would plug in 0, 1, 2, and then here 62.5, 300, and 850. Stat, arrow over to Calc, and then you have to use the exponential regression. Once you do that, it's going to give you your value for A and your value for B. Okay, and notice that in both of these, that your base value is the same. So a few things you want to look for on a multiple choice test. It says write an exponential function in there. So if you see a log in the answer of the equation, will you please cancel that out right away? If you see a function that's not exponential, cancel it out. Okay, don't even entertain that. Okay, so you're using an exponential function. And then no matter what equation you use, you should get some form of this. So if you use this value, you got around 46,600 and something, so I just rounded it to 46,700, measured in thousands, okay, which if you multiply that, it is the 46.7 million. And then one thing I didn't like about this question, and it's something that I changed on your test, is I thought this was confusing. It says in 3 years. It should say 3 years after 2004. Okay, so if it's 3 years after 2004, that means you're going to find this for the year 2007. So if this is 0, 1, 2, this would be 3, this would be 4, this would be 5. And then whatever your function is, you would plug that in for x. Okay, so if you have y equals the 68.24, 3.69 to the x, okay, you would plug in x is 5. Yeah, and so you get around 46,684, and that's measured in thousands. Okay, so then I just rounded it up to 46,700 in thousands. Okay, and then if you used a different equation and you're unsure if you did the right thing, let me know. All right, and then the last part we have is the vocab. Did you guys get to check your answers for that? Oh, okay. Notice that with some of the vocab, there were key words in it. Okay, so for example, for 23, it says an equation that contains one or more exponential expressions. So if it's an equation and it has something exponential in it, it has to be an exponential equation. Okay, exponential equation. This was decay, and this was growth. Okay, so the decay, exponential growth. The statistical method with the data set is the regression. Remember, we use exponential reg. That stands for exponential regression. Okay, that's why 26 is E. This was A, this was D. Okay, and then this one, it's a function of this form. Okay, this form is exponential, so exponential function, C. How did you guys do on the matching? Okay, so I know some of them were kind of funky. Okay, I think I put the easier ones on your test. Okay, but again, some of these are going to say like the function, the equation.